Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us move to the paper 2 of 2015 JEE Advance. In paper 2, we'll start with question number 1, which we have here mentioned question number 21. That is the first question of paper number 2. So let us begin with question number 21. Hello students, let us solve this paper 2. This is paper 2 starts from here. In your exam, you will get question number 1, 2 like that. Here we have taken this is 21. This is the first question of paper 2, 2015. The energy of a system as a function of time is given by this. Energy of a system is given by this. Is a time variable energy. And where alpha is this alpha is this. The measurement of A has an error of 1.25%. If the error in the measurement of time is this, so measurement of this is the error in time and this is the error in A. This is the percentage error given. The percentage error in the value of E of t, that is energy, the measurement of energy as a function of time after or at 5 seconds. What is the error in 5 seconds? So the aim is to find percentage error in time in energy at 5 seconds. Now the function which is given is E equals to a square e raised to the power minus alpha t. This is a function of time. E as a function of time, like so. So first of all, take log both sides of the equation. Taking log both sides of equation, we have log of E equals to log of, this is the product, so it is log of a square plus so now this is log of E equals to 2 log of A, and this cancels and this becomes minus alpha t. So this is the equation. And to find the percentage error, this equation is differentiated. So differentiating equation 1, with respect to anything, say time, say with respect to time, say, then we'll have the equation is log E equals to 2 log of A minus alpha t. Then this will be 1 by E, and d by dt. This will be 2 log A, which is 2 1 by A dA by dt minus alpha. This will be the differentiation of this equation with respect to time. Then if I write this one, d by e dt, here 2 dA by a dt. If I take the LCM, this becomes, okay, then I will write this alpha, this I take to this side and then multiply throughout the equation dt. If I multiply dt, this becomes alpha dt over dt. I can write like that. Then this dt will cancel out. Then this is d by e equals to 2 minus alpha. This t is there, one t is there, I just left it out. This t is there, so this is alpha into t dt. This is alpha t, this dt by alpha dt. Alpha t is there, this is alpha t, this is dt, d by dt. If I, so we'll differentiate the equation 1 with respect to time. That is, we have the equation log e equals to 2 log of a minus alpha of t. This is what we got. Now differentiate this with respect to time. We'll get d by e equals to, this is 2 dA by a minus alpha t dt by t in terms of percentage. So for error this will be plus, for error this will be plus, and into 100 into 100. This is the percentage error. So percentage error in E, percentage error in the measurement of E will be 2 times percentage error in the measurement of A, which is given as 1.25. So 1.25% plus alpha t. Alpha is 0.2, t is 5. So 0.2 into 5 into the time, the measurement of error is 1.5%. So it is 1.5 in terms of percentage. So answer will be in percentage. This is 1.5 percentage. So this is 2.5% plus this is 1.5. This is 1. This is 1.5. This is 1. This is 1.5%. So this comes out to be 2 plus 1, 3, 5, 4%. So the percentage error in the measurement of E will be 4%. So this is the answer to this question. The answer to this question is that at time t equals 5, the percentage error will be 4%. This is the answer. This is integer type, so answer is 4%. Okay, thank you.